Folks, this video is ununderwritten by Microsoft. Microsoft, you make horrible products. I've paid for your Windows key, I've entered it, and suddenly a year and a half later, you're asking for me to activate it again. This annoying window that has just popped up for no reason whatsoever. Microsoft, you make horrible products. If you'd like me to take this message down and stop bad-mouthing your products, please give me the sum of $199 via Venmo. Reach out to find out how to do that, or better yet, just improve your products, and I will take this down. Let's get to the video. All right, folks, we're looking at giving the equation to the tangent line of this function right here, f of x equals 2e to the x minus 12x plus 3. We're asking to find the equation of the tangent line at x equals 0. In a moment, after we're done with this problem, we will go down and we will actually look at the graph of this function, and we will actually go draw the tangent line that we obtain from it, and we'll get a nice visualization of what we've just done. But before we do that, I want to just give ourselves a kind of a more generic abstract picture. So we have this arbitrary function, I'm not sure what it is, f of x here, and we're trying to find the equation of the tangent line at some a value. So here would be the order pair a comma f of a on the graph of this function. And what are we trying to do? We're trying to find the equation of the line that's tangent to the curve at that point. And so how do we do this? Well, as a reminder, the way we find the equation of any line, I guess I should say non-vertical line, is using our point-slope formula line. And the reason why this is really beneficial is that this requires us only to need to know two things. We need to know a point on the line, and in our case we do, and we need to know the slope of this line. And in our case, we can find that slope by computing the derivative. So this is not how we usually give the equation of the tangent line in a calculus class. It's a little bit too generic, and we want to tailor it. So this is always true, but we want to tailor this definition for our particular function. So we're going to use y minus f of a is equal to, and here I'll write the x minus a, and then what goes here? What goes here is the slope of the tangent line at the point x equals a. So in our case, here we're doing this at x equals 0, so the a value will be 0. Let's go ahead and give this a shot. Okay. So in order to fill in, here's the equation of the tangent line that we want to fill in, and in order to fill all of this in, we need to compute the various components. So we already have said that in our case a is equal to 0, so we've said a is equal to 0. At some point we're going to need to know what f prime of a is, f of a is, and that's just f of 0, which would be 2e to the 0 minus 12 times 0 plus 3. And if we evaluate all of that, let's see here, this would be 2 times 1 minus 0 plus 3. I think we get the value 5. So f of a is equal to 5. Likewise, we're going to need to know what f prime of a is. Well, one way to compute f prime of a, I think it's easiest to first find the derivative as a function. So I'll compute f prime of x, and this would be 2e to the x minus 12. And you don't have to write this, but if you find it helpful, you could put plus 0 for the derivative of that constant term 3, although I usually won't. So now we can go ahead and evaluate the derivative at a. We're computing f prime of a. That's the same thing as evaluating f prime of 0, which is 2e to the 0 minus 12, which is equal to minus 10. Given that e to the 0 is 1, so we'd have 2 times 1, or 2, minus 12, and that's how I get the minus 10. Okay, so now we've got, if you take a look here, we know what a is, we know what f of a is, it's 5, and we know what f prime of a is, it's minus 10, and so I can go back to this generic equation of the tangent line and fill in all of the components. So here we'd have y minus 5 is equal to negative 10 times x minus 0. So notice that this was our a value right here, this was our f prime of a, and this was our f of a in this case. And so if we were finding the equation of a tangent line at a different point, we would have to find these different three components, but the overall structure would be the same. So I'm fine with you leaving your answer this way. I'm going to take it one step further and write it this way. And I'm also fine with you leaving your answer this way, but it is customary to put your answer into y equals mx plus b form. And so to do that, I'll distribute this minus 10 through if necessary, and then add this 5 over and collect like terms. So here is our equation of the tangent line at x equals 0. We can now go look at the graph of this function and see exactly that. There's the ordered pair 0, 5. That was our a comma f of a that we just found. And then we just came up with the equation of the tangent line. And I'm going to try my best to sketch this on here, folks. It's not going to be the prettiest. Let's see here. If we go over 1, we'd go down 10. And if we go back 1, we'd go up 10. So I'm going to try my best to sketch this. It's not going to be pretty on my little graphing utility, but there we go. So the equation of this line right here is y equals negative 10x plus 5. And the slope of this line, if we wanted to go label it somewhere on here, the slope of this line is the slope negative 10, which was just our f prime of a. So folks, hopefully this gives you a good sense of how we're computing the equations of these tangent lines. Let me know if you have any questions. I'm going to leave you to go ahead and try to answer these 2 remaining questions where you're going to figure out where f has horizontal tangent lines and to do some more work with that. So give that a shot on your own, and do please feel free to come by and see me during office hours if you have questions on this. So one more time, folks, this video was underwritten by Microsoft. Microsoft, you make horrible products. I've paid for your Windows key. Actually, I've paid for many of them over the years. And here we are 1.5 years later, and you're asking me to activate it again, as you can see in my window, even though I've paid for it. Now I have to go digging through my garage to find your stupid key to enter it. Microsoft, if you'd like me to stop bad-mouthing your products, please Venmo me $199, or better yet, just improve your product. Thank you.